So we are going to start our next part of the lab 2, which is lab 2C. So in this part we'll first start with the binary subtraction. Okay. Now we already know about the binary numbers, and we also tried the binary addition last class. So today we'll try the binary subtraction. But before I start the subtraction, let me tell you just a couple of things before the about the subtraction. The binary subtraction actually has a couple of different ways of doing the subtraction, but in this at this point in this class we'll actually talk about the subtraction all the digital devices does. Okay, there is different way of doing the subtraction. In all of the subtraction you actually end up having the same difference, like same result. Okay, but we'll learn the method which computer or any digital device actually applies, because in this class we are mostly interested about the digital circuit, right? So we also want that's why we want to know how a computer actually does the subtraction. And also, I'm not sure you have ever heard these, that any digital device, including the computer, can actually do only one arithmetic operation, which is actually addition. It cannot actually do anything else. So you might be wondering that how the whole world is running on the digital world, because every single digital device you use, like your computer, cell phone, tablets, like cell phones, pretty much everything is can do only one single arithmetic operation, which is addition, and every other operation it does, like subtraction, multiplication, division, whatever you tell, everything is actually defined in terms of addition. So you will probably get a feel here, because since even we are doing the subtraction here, we'll actually show you all the steps computer does to do the subtraction, but in none of the steps you will see that there is a subtraction really done, but at the end you will get the answer. And that's the great part of it, that you will not see the subtraction is there, but the answer you will get always without doing the subtraction in real. Now let's see, this is how actually we do the subtraction. So if you do any subtraction, you will always have two different numbers, right? The first number and second number. The first number is actually called minuend, the number that you will have always at the first or the top. Okay, and the second number is called subtrahend. These are the names of the numbers that you will be subtracting, right? So we just want to know what are the names, how they are called. So the first number is called minuend, and the second number that is being subtracted is called subtrahend. Now I actually listed both numbers here, and at the right side I listed those numbers. So this is my step 1. The step 1 will identify which one is subtrahend and which one is minuend. Okay, it's very easy, right? So we are given those two numbers already in the question. Step 2. In the step 2, we'll find ones complement of subtrahend. What is that? First of all, subtrahend is the second number, right? So we'll be working with the second number, and then we'll find the ones complement. Now what is ones complement? Ones complement is actually very easy, because all you have to do is you actually have to flip every single bit of the subtrahend. What do I mean by flip? Remember, these are all binary numbers, right? So you only have two different digits, 0 and 1. So flipping means if it is 1, make it 0. If it is 0, make it 1. That's it. So this is how we actually flip it. Now this is my second number, right? My minuend. I'm flipping it. Do you see I flipped the green one? Look at the blue number and look at the green number. All I did is just flip all the bit. If it is 1, I made it 0. If it is 0, I made it 1. That's it. So this flipping, after the flipping, the new number I got is called ones complement. And since I worked with only the subtrahend, this is the ones complement of the subtrahend. Okay, so that's our step 2, which is again very easy step. In the step 3, we'll find the two's complement of the subtrahend. We already got the ones complement, and now we know how we got the ones complement, right? The two's complement is also very easy. All you have to do is remember the two's ones complement you got in the last step. We'll just add 1 with that. Let me show you how we do it. Remember the green number? We got this green number in the last step, right? This is actually the ones complement of the subtrahend. All we have to do is, to get the two's complement, all we have to do is just add 1. How do I add 1? Just like this. So we'll be adding 1 just using the binary addition rule. Remember, we know how to add the binary numbers, right? We just learned that in the last class. So again, we just followed the steps here. So look at this. 1 plus 1 is 0, and there is a carry of 1, right? So your carry will be here. I did not write the carry here. I did not write the carry here because I know that you already know there will be a carry. So you just have a carry, and then that carry is here, 0 plus 1. And then every other digit will be remain same, right? Because that's just, So this new number, the maroon one, is our 2's complement of the subtrahend. So up to this point, you probably have noticed we only worked with subtrahend, nothing else, right? Because at the very beginning, we identified the minuend and the subtrahend. In the second step, we converted the we found the first complement of the subtrahend. In the third step, we found the second complement, 2's complement of the subtrahend. This is our third step. Any question up to this point? Okay, now let's move on and let's look at the fourth step. Step 4 is also easy. All you have to do is add minuend and 2's complement. Now what was my minuend again? Minuend was my first number, right? This was my minuend. This this brown number, right? That's my minuend. And what is my 2's complement? 2's complement is the number that I just got in the last step, right? After adding 1 with the first complement of the subtrahend, that maroon number. So I'm adding this brown and the maroon number in this step, which is the step 4. Now look at this. Up to this point, we have not done any subtraction yet, right? Because we are just doing addition here instead of doing the subtraction. Now once you do the addition, you know how to do the addition, right? Because we know the binary rules, right? We'll just be following those rules to do this addition. So let's say, for an example, I did this addition. So I did not write all those like the carries, because I know that you know that there will be carry in some cases. So you just apply those Boolean rule the binary rules for addition, right? So once I did that, I actually got the sum of these two numbers, right? The minuend and the 2's complement of the subtrahend. Now, if you look at here, there is a carry at the very end. Do you see it? Did you notice there is a carry? Look at my laser. Do you see this carry here at the very end? There is a carry at the very end because you see here these numbers are actually 8-bit, right? There are 8 digits in all of these numbers, but in the sum there are actually 9 digits, right? The reason there is 9 because this is a carry at the very end. So you may have this carry, you may not have this carry, depending on the numbers, right? It depends, meaning whatever the number you have. So at this point, based on whatever I have a carry. You may have carry, you may not have carry. It depends. At the very end, okay? Now, step 5, if you have a carry, all you have to do is, at the very end, if you have a carry, you ignore the carry. See, I ignored it here. See, I crossed that 1. Now, this step is sort of like optional, because in the sense that if you don't have a carry at the end, you actually don't need this step. That's what I'm saying. If you have a carry at the very, very end, at the left side, okay, then you have to ignore that 1. And once you did that, you got the remaining part of that number. Look at this. I'm getting the remaining part, right? So 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1. Now, this is actually the difference of both numbers that we have at the top. Remember, we are trying to find the subtraction, right? I'm saying the result of the subtraction, which is called difference. So this is actually the difference. Now, if you look at all these steps, like up to step 5, I think you have seen that in none of the steps we actually did any subtraction, right? All we did was, at the beginning, we tried to find the first complement of the subtrahend, then 2's complement of the subtrahend, and then we added the 2's complement of the subtrahend with the minuend, and we are done. But we have to ignore 1 if we have any, at the end. That's the step 5. Now, this is exactly how any digital device does the subtraction. It's a little bit longer than the expected because we have a couple of steps, but this is exactly how all the subtraction is done. So we have just these 5 steps for every subtraction. I think once you try one. I think it will be extremely easy. So let's go to the lab section and let's try the subtractions. And again, in case you don't know where this slide is, if you go to the lab 2, you will actually find this slide, because we have all those, all the lecture, everything, the PowerPoint there. In case you want to see all the slide again, just to look at all the steps one more time, you can go there and also try the lab 2B. I'm saying 2C. The first couple of questions are actually subtraction. Let's try those subtraction, and then we'll move on to the next part. So I'll give you a pause here so that you can complete the subtraction. And again, as you have noticed that we have a couple of steps, so make sure you use page, I'm saying you use paper and pen and write it down. I'm saying don't try everything on your head, okay? You have to write it down and then, write the steps and then find the answer at the end. Let me give a pause here so that you can try and complete these subtractions. So let's try some hexadecimal subtraction. So since we already know about the hexadecimal numbers, so we also know the hexadecimal digits. So the idea of hexadecimal subtraction is pretty similar to the decimal subtraction. So let's try it. So again, we have two numbers here. So we'll try the subtraction. So we'll put two numbers just aligned, and then we'll start from the very right side, just like how we do the decimal subtraction. So let's look at the very right column. So what we are subtracting? A minus 1. Now what is A again? A is 10, right? So A minus 1 is what? 9. Very simple. So we're just writing 9 here. Now the next column, this is 1 minus B. Now we have a little bit of trouble because B is what? 11, right? So you are actually trying to subtract 11 from 1, which is not possible. So think about the decimal subtraction. What do? If you cannot subtract, what do? You actually borrow from the left side, right? You borrow from left side. This is exactly what we are going to do here. So we'll actually borrow from here, from the left side. Now, this is, we have at the left side, right, which is 1. So we'll borrow 1 here. Now, the only difference here, in the decimal subtraction, when you borrow 1, how much you add? You add 10, right? If you borrow 1, you add 10. Now remember, the hexadecimal number system is a 16-base number system, right? So that means if you borrow 1, you will actually add 16, not 10. That's the difference. Now this is how it works. So when you borrow 1, look at this. I borrowed 1. Now this becomes 17. Why? Because you added 16 with this column. We already had a 1 there, right? But you borrowed 16. Now it's 16 plus 1. That becomes 17. But the column where you borrowed, we had a 1 there. Now the 1 is gone, it becomes 0. Right? So you updated those columns. So now this column becomes 0, and this column becomes 17 because we borrowed 1, and because of the borrow, we added 16. Now, I think we can do the subtraction, right? Because this is 17, and B means 11, right? 17 minus 11 is very simple, is 6, right? Again, we are in trouble with the next column, because in the next column, we are trying to subtract 2 from 0, right? Again, we are in trouble because you can subtract 2 from 0. That means you have to borrow from the left side. So what do you have in the left side? 7, right? So you can definitely borrow 1 from there. And what happens? If you borrow 1, this is what happens. If you borrow 1 from 7, that becomes 6. And if you borrow 1 to here, remember we had 0 here? We had a 0, right? So, but since we borrowed 1, we just added 16 with the 0. That becomes 16, right? Anytime you borrow 1, you actually add 16. Now you can easily do the subtraction, because this is going to be 16 minus 2, which is 14. Now what is 14 in hex? E, right? So we are going to write E here. And the very last column at the left side, 6 minus 5 is just 1. And that's it. So let's try the next couple of questions and complete all the hex subtraction and then submit lab 2C. Now once you submit it, you'll see your grade, and in case you don't like it, just like any other quizzes, you can submit it again, right? For a better grade. You pretty much see the similar question every time you start a new lab. So we are pretty much done with lab 2C. Let's finish this X subtraction, then we'll actually move on to the next part. I'll give a pause here just for a couple of minutes.